We are going to talk about pointer arithmetic. Okay, pointer arithmetic. What it means is you can add one plus one or plus two minus one um, minus two, or a pointer. Let's say PTR minus I could be something. So when you do operations like this, like additional or subtraction operations on pointer variables, they actually point to a different location. For instance, we have an array. Pretend we have an array, and it has three integer elements. Let's call this as 0, 1, and 2. And they have their own addresses, right? Let's pretend this is 440 is the address, 44 is the address. This is the integer array. That means we have 4 bytes. So each byte has an address. So you, for integer, the next address is 44, and this is 48, address of this cell. This is an IA array. And when you declare a pointer that points to wherever IA is pointing to, that is PTR equal to IA, right? And if you print the addresses of this indices, right? This is 0 index 1 and 2. Okay, let's print that. At the same time, let's go back to our topic. PTR equal wherever IA is pointing to, right? And we can say PTR equal to PTR plus 1. What does it mean? That means this is a pointer arithmetic. Remember that. Pointer is of type integer. So when you say increment my pointer by 1, that means point my pointer not by 1 byte. This is a 4 bytes. So it increments the address by 4. Okay? Remember that. This is addition not by 1 but by 4, because it is integer pointer. Remember that. Alright. So pointer plus pointer is pointing to IA, plus 1 will point to 44. Similarly, now that pointer is pointing to here, if you say pointer equal to pointer plus 1, now this will point to the here. So this pointer is pointing to here. The second statement, okay, the second statement increments the address by 1. That means because of the integer pointer, it increments by 4. And if you increment by 1 more, it goes to the next address. You can also do pointer equal to pointer minus 1. Okay, you could do that, or you could do minus 2. So if I do minus 2, what does it mean? Go back to the beginning, by go back by 2 addresses. All right, this kind of navigating the memory locations using pointer arithmetic, okay, is very efficient in systems programming. Okay, so that is what is called pointer arithmetic. You can use a pointer point to one location and use the offset like +1, +2, or whatever that is to navigate around the memory locations, right? So let's take an example. In here, I have written a program for you guys. Pointer, it has 3 elements because integer. Okay, let me just okay, pointer now pointing to IA, which is the first element. I'm printing the address of IA, the first element. So I'm going to repeat like this: print IA, and then print the pointer, then print the second IA plus 1 and increment the pointer, so print that address. So I'm printing all the addresses here. So this program will get you that. Okay, I'm pointer, I'm sorry, pointer plus 1, again pointer plus 1. You can also change that to, if you want, you can do -1 too. Sorry. All right. So you can do all this kind of pointer arithmetic using pointers. So that is one example. All right. Let me copy this. All right. So if you run the program, you will see a printed. Let's look at this pointer alone. First pointer ends at 40. The next pointer +1 I did is 44. See that it incremented by 4 addresses. Then I did pointer plus pointer 1. It increased by 4 more addresses, 48. So go over this program again to see what it does. I'm going to run the other program, arithmetic 2. Here I'm going to change both of them to character. Okay. Now what happens when I do character? Okay, let's go back to the whiteboard. Okay, let's copy this into the PowerPoint. Okay, let's go back here, erase it, and now we are dealing with character pointer, and IA is also character, right? It's a character array. That means 1 byte each. Now pointer pointing to IA, yeah. So pointer equal to pointer plus 1. What does it mean? This means first pointer is pointing to here because IA is pointing to here. Pointer equal to pointer plus 1, it goes here, and pointer equal to pointer plus 1. If you do it again, you're updating the pointer to look here. Now the addresses, when you print, they don't jump by 4, they jump by 1 because we are dealing with character pointers. Okay, let's try that. Okay, let me remove addresses for now. We don't need that. Okay, so let's try that. Okay, I compiled it, no problem. Clear. Do it. You see that? Because of character array, the addresses go by 1 1 each because of the byte. So if a character array, it goes by 1 byte. Okay, 1 byte. So it jumps by 1 address. All right. So remember that this is a very important concept that you guys have to remember for the rest of your life. Okay. Character pointer, difference between a character pointer and integer pointer. All right. So let me revise it again. This is a character pointer array, but in case you have integer, this goes, if it is integer pointer, it jumps by 4 bytes or 4 addresses, right? Whereas a character goes by 1 address or 1 byte. Okay, this is actually 4 bytes, right? We saw that at the beginning of the course. So this is, each is a 4 bytes. So when you say pointer equal to pointer plus 1, when it is integer, it jumps by 4 addresses. Whereas a character pointer jumps by 1 address when you do pointer arithmetic. Right? So in case of short, how many bytes it will jump or how many addresses it jumps, that's try it out. Okay? Thank you.